There is a kind of darkness that most people never truly encounter. You may think you know what darkness is. You've felt it when the lights go out, when you close your eyes in a quiet room, when night settles over your neighborhood, and the world outside your window goes soft and still. That familiar darkness feels complete, doesn't it? It feels like the end of something, like the world pressing gently against the edges of your vision, asking you to rest. But that darkness, the darkness you've known your whole life, is not real darkness. Not in the way the universe understands the word. What you felt when you turn off the lamp beside your bed is more like a dimming, a softening of the light that surrounds you constantly, invisibly, in ways your eyes were never meant to notice. The glow from a streetlight 2 blocks away, the moon somewhere above the clouds, the faint blue pulse of an electronic device, the scatter of city light against the low ceiling of the atmosphere. You have been, every night of your life, bathed in light so gentle and diffuse that your brain simply calls it darkness and lets you sleep. The true darkness, the darkness this video is going to take you into tonight, is something else entirely. It is a darkness so absolute, so complete, so unlike anything your nervous system evolved to process, that the astronauts who have encountered it struggled to find words for what it felt like. Not the darkness of a room, not the darkness of a cave. Something deeper, something that doesn't just surround you, but seems to replace everything, as though the concept of seeing itself has been quietly, permanently revoked. Before we drift any further into that vast dark, if you find yourself drawn to these slow journeys through the cosmos, through the deep questions of space and time and what it all means, take a moment to like this video and subscribe to this channel. It's a small gesture, but it helps more curious, sleepy minds find their way here, too. This quiet space where the universe unfolds at a pace you can actually feel. Now let's go somewhere very, very dark. Start with what you already know. When you're in your home at night, all the lights off, curtains drawn, the room feels black. You might not be able to see your hand in front of your face. Your brain registers this as darkness, real and total. But your eyes are still working. They are still receiving photons, still processing information, still constructing a faint map of the space around you. Your pupils have opened as wide as they can. The rod cells deep in your retina, those ancient light-sensitive structures shaped by millions of years of evolution, are doing their job with extraordinary delicacy. Given 20 minutes, they can reach a sensitivity so fine that they respond to individual photons, individual particles of light. And on a night that feels completely dark to you, those cells are busy. Light leaks in everywhere on Earth, from the thin line under the door, from the digital clock on the nightstand, from the slow orange bruise of a city glowing on the horizon 20 miles away. The atmosphere above you is not empty. It scatters the light of human civilization across the entire sky, creating a glow so uniform and pervasive that it has become invisible to us, indistinguishable from what we call night. Even the air itself glows faintly, a chemical process called air glow. A soft luminescence produced by molecules reacting in the upper atmosphere. There is light in the Milky Way arcing overhead, even when clouds cover it. There is zodiacal light, a faint cone of luminescence rising from the horizon where the sun has set, caused by dust in the inner solar system catching and scattering sunlight long after sunset. You are swimming in light, always, even in the dark. This is not a flaw. It is simply the nature of living at the bottom of an atmosphere, on a wet, spinning rock, circling an average star in the suburbs of a galaxy with 400 billion other stars. Light is everywhere here. It bounces off everything. It fills the gaps between objects, softening shadows, giving your brain the gentle, constant reassurance that the world still exists and that you are still inside it. Now imagine the moment that reassurance is taken away entirely. The first astronauts to travel beyond Earth's atmosphere described something they hadn't fully anticipated. Not the beauty of the stars, which they had prepared for. Not the curvature of the Earth below them, which they had seen in photographs. What surprised them most, what stayed with them longest, was the darkness. not the darkness looking toward space from the surface, where you still have the atmosphere between you and the void. The darkness on the other side of the glass. The darkness that existed not as an absence of light but as a presence of something else, something heavier and more absolute than anything night on Earth had ever offered. Bruce McCandless, the first human being to perform an untethered spacewalk, floating free of any spacecraft in 1984, described looking away from Earth, away from the sun, into the deep space beyond. He said the darkness was unlike anything he had experienced before. Complete, physical, almost. A darkness so total that he could not see his own hand when he extended it into the shadow. Not dimly, not faintly, not at all. His hand was simply gone, as though it had ceased to exist. The darkness didn't stop at the edge of his vision. It went on. He understood, in a way that no amount of reading or training or preparation had made real until that moment, that it went on essentially forever. And why is this? Why is space so incomprehensibly dark when the universe is full of stars? The answer is simpler than you might expect, and more strange. Space is dark because it is empty. Not empty the way a room is empty when the furniture has been moved out, not empty the way a field is empty at night. Empty in a way that has no proper equivalent in human experience. In the space between stars, there is roughly 1 atom per cubic centimeter. One single atom in a volume of space the size of a sugar cube. On Earth, that same sugar cube of air contains approximately 27 billion atoms. 27 followed by 18 zeros. The difference between those two numbers is so large that comparing them feels almost meaningless. The way it feels meaningless to compare the age of a mayfly to the age of a mountain. In that emptiness, light travels. Enormous quantities of light travel through space at all times, photons streaming outward from billions of stars, crossing the void in every direction simultaneously. You could be, right now, traveling through a beam of light originating from a star on the far side of the galaxy, and you would not see it. You would not feel it. You would not know. Because light is only visible when it interacts with something, when it bounces off a surface, when it enters your eye, when it strikes a particle of dust or a molecule of gas. In the void between the stars, there is nothing for the light to touch, and so it passes through, invisible, carrying information across cosmic distances to nowhere in particular. Darkness, then, is not the absence of light sources. There are light sources everywhere. Darkness is the absence of light reaching your eyes. And in space, unless you are looking directly at a star, unless a photon from that star is traveling on a path that ends precisely at your retina, you see nothing. Think about what that means. You could be floating in the middle of a beam of sunlight, fully surrounded by the energy pouring off our star, and if you looked sideways, away from the sun, you would see only black. The light would be passing through you, around you, in every direction, and none of it would reach your eyes unless it had something to reflect off. Without that reflection, without something to scatter even a fraction of the photons toward you, the universe around you is dark. The light is real. The darkness is also real. Both things are true at the same time. That is one of the stranger facts of the cosmos. Imagine a spacecraft drifting in the dark between star systems, not near any planet, not near any moon or asteroid, just in the open, empty, vast interstellar medium. You look out the window away from the distant stars. What you see is not the darkness of a painted wall. It is not the darkness of a moonless night. It is a void so complete that your visual cortex, the part of your brain that has been processing sight every waking moment of your life, has nothing to process. No variation in tone, no texture, no depth, no edge where one shade of dark meets another. Your rod cells, those extraordinarily sensitive receptors that can fire in response to a single photon under ideal conditions, receive no signal at all. Zero. This is a condition your nervous system was not designed to encounter. Your brain, denied. Visual input does something quietly unsettling. It waits. It searches. It begins to manufacture patterns in the noise, the way it always does, because the alternative, admitting that there is simply nothing there, is something it has never had to do before. You might see faint smears of color at the edges of your vision, geometric shapes that aren't there, the impression of movement in a place where nothing moves. Your brain is not hallucinating exactly. It is doing what it was built to do, finding signals in static, constructing a world from whatever information is available. When there is no information, it invents some. It cannot help itself. This is the darkness that most of the universe is made of. Not the darkness you fall asleep to, but this. The empty, absolute silent dark between the lights, and the lights themselves, when you understand the distances between them, feel very far away. The nearest star to our sun is a small red dwarf called Proxima Centauri, sitting at a distance of about 4.24 light-years. That number sounds manageable until you convert it. It is roughly 25 trillion miles, 25 followed by 12 zeros. If you could somehow travel at the speed of a commercial airplane, about 500 miles per hour, it would take you approximately 5.7 million years to get there. The age of our entire species, from the first hominids walking upright in East Africa to this moment, is less than a quarter of that journey. Now imagine standing not at Proxima Centauri, not at our sun, but somewhere in the middle of that distance, halfway between. 2 light years from either star. In any direction you turned, you would see a bright star. Our sun in one direction, Proxima in another, both reduced at that distance to brilliant points of light. Not the great disk of warmth and fire we know from standing on Earth, not the thing that fills your closed eyelids with red on a summer afternoon. Just a point. Bright, yes, the brightest thing in your sky, but just a point, casting no shadows, illuminating nothing around you, giving no warmth that any instrument could detect at that distance. And in every other direction, darkness, vast, quiet, still darkness extending for trillions of miles before it encounters anything at all. You would have no ground beneath you, no horizon to orient yourself, no sense of up or down, because those concepts require gravity, and gravity at that remove from anything. Massive is nearly non-existent. You would be floating in 3 dimensions of dark, tethered to nothing, with only 2 faint points of light to tell you the universe still existed. The psychological weight of that, the complete and total dissolution of every reference point a human mind requires to feel located, to feel real, would be unlike anything any of us have ever experienced. And yet, this is ordinary space, not the darkest region of the cosmos, not the void between galaxies or the interior of a black hole. Just the normal, average, everyday space between 2 nearby stars in a busy corner of the Milky Way. The universe is mostly this. It is easy to forget, looking up at a clear night sky, how empty the thing actually is. From a dark field on Earth, on a perfect night with no moon, you might see 5,000 stars with your naked eye, maybe a bit more under ideal conditions. They seem to crowd the sky, dense near the band of the Milky Way, scattered elsewhere, but present everywhere you look. It feels full, populated, alive with light. But every one of those stars is an island. Every single point of light you see is separated from its neighbors by distances so enormous that the light between them is simply not enough to illuminate anything. The sky looks crowded because of what your eyes cannot resolve, the darkness between each star. If you could see those distances truly to scale, the sky would look almost entirely empty. A few faint sparks separated by oceans of black. And this is still inside our galaxy, still within the warm, relatively dense, stellar neighborhood of the Milky Way. Venture farther out, past the edge of the disk, into the space between galaxies, and the darkness deepens in ways that require a new vocabulary to describe. The Milky Way and our nearest large neighbor, the Andromeda Galaxy, are separated by about 2.5 million light-years, 15 quintillion miles. That is 15 followed by 18 zeros. The space between them is not empty the way interstellar space is empty. It is emptier. The density of matter in the intergalactic void drops to roughly 1 atom per cubic meter, not per cubic centimeter, per cubic meter. one atom in a space the size of a large refrigerator. Imagine a spacecraft drifting in that void. Halfway between the two galaxies, 1.25 million light-years from either. You look in one direction and see the Milky Way. Not as it looks from inside, not as the faint river of light you can see from a dark field on Earth, but as an object, a spiral galaxy, a faint smudge of ancient light fading into the background. You look the other way and see Andromeda, another faint smudge. In every other direction, nothing. Not the nothing of an empty room, but the nothing of genuine cosmic void, extending for hundreds of thousands of light years before it encounters anything denser than a stray hydrogen atom. Everything humanity has ever done is in one of those two faint smudges. Every city ever built, every war ever fought, every child ever born, every song ever sung, contained in a blur of light that from this distance would be barely visible, easily overlooked, lost against the background if you weren't specifically looking for it. That thought is not meant to make you feel small in a frightening way. There is something else in it, something quieter and more interesting. If you sit with it long enough, the smallness stops feeling like a threat and starts feeling like relief. Your worries, the ones that feel enormous tonight as you lie here in the dark, the things that filled your day with weight and friction, they exist in that smudge. They are real, but they are also, in the most literal sense, a tiny, temporary disturbance in one corner of one galaxy in a universe that extends in darkness beyond anything our minds can hold. You are very small, and somehow that is one of the most comforting things there is to know. Now, there is a question hiding inside all of this, a question that has troubled astronomers and philosophers for centuries. If the universe is full of stars, billions of them in every galaxy, and hundreds of billions of galaxies filling all of space, why is the night sky dark? Every direction you look should eventually lead to a star. Every line of sight should eventually intersect with a surface radiating light. The night sky should blaze like the surface of a sun in every direction, a uniform wall of fire in every direction you turn. And yet it is dark. This puzzle has a name. Olber's paradox, named for a 19th century German physician and amateur astronomer who wrote about it, though the problem had been noticed long before him. The darkness of the night sky, so obvious, so easy to overlook, turns out to be one of the most profound clues the universe has given us about its own nature. The answer to the paradox tells you something extraordinary. The universe is not infinitely old. Light travels at a finite speed, approximately 186,000 miles per second, which sounds very fast until you compare it to the distances involved. The universe has existed for about 13.8 billion years, which means we can only receive light from objects whose light has had time to reach us. Anything farther away than 13.8 billion light-years, its light has not arrived yet. The universe has an edge, not a physical wall, but a horizon of time, a limit to how far we can see, not because space ends, but because time began. Beyond that horizon, galaxies exist, probably countless of them, but their light is still traveling toward us, has been traveling for billions of years, will eventually arrive if the universe cooperates. In the meantime, those galaxies contribute nothing to our sky. They are invisible, hidden not by distance alone, but by time. And even the galaxies within our observable horizon are receding. The universe is expanding. Every galaxy is moving away from every other galaxy, carried along by the expansion of space itself, not moving through space, but moving with space as space itself stretches. The farther away a galaxy is, the faster it appears to be receding, and as it recedes, the light it emits is stretched. Wavelengths grow longer, colors shift toward the red. For the most distant galaxies, the light has been stretched so far that it moves entirely out of the visible spectrum, into the infrared, into microwave frequencies our eyes cannot detect. These galaxies are still there. Their light is still reaching us, but we cannot see it. Our biology was not built to perceive those wavelengths, so they vanish from our sky. contributing to the darkness even as their light passes through us. The darkness of the night sky, that simple, familiar darkness you have looked up into all your life, is the signature of a universe with a beginning, a universe that is expanding, a universe that is, in a very precise and measurable way, not eternal and static but young and dynamic and evolving. The darkness is proof of the Big Bang, written in every empty patch of sky you have ever seen. Lie with that for a moment. Look up, or just imagine looking up, into the black space between stars. That blackness is not emptiness in the way we usually think of it. It is a window into time. It is the space where the light has not arrived yet, where the universe is still unfolding, still expanding, still becoming whatever it is going to be. The darkness is not the absence of the universe. It is the leading edge of it. There is one more layer to the darkness worth exploring before we rest tonight. A layer that exists not in deep space but in the fundamental structure of the cosmos itself. Scientists studying the universe have arrived at a strange and humbling conclusion. The matter we can see, the stars and galaxies and nebulae and planets and dust clouds, everything that emits or reflects or absorbs light, everything that our telescopes can detect in any wavelength, represents only about 5% of the total content of the universe. 5%. The rest is dark. About 27% is what physicists call dark matter. Not dark in the way space is dark. Dark in the sense of invisible. It does not emit light. It does not absorb light. It does not reflect it. It passes through ordinary matter almost without interaction. Right now, as you lie here, dark matter is passing through you. Through the walls of your room. Through the earth itself. Billions of particles traveling in every direction simultaneously, and you feel nothing, see nothing, know nothing of their passage. We know dark matter exists because we can measure its gravity. We can see the way it bends light from distant galaxies, the way it holds galaxies together when the ordinary matter inside them should not have enough gravity to do so. It is there. It is real. It is massive. But it is, to every sense we possess, completely and utterly invisible. The remaining 68% or so is something stranger still. Dark energy, a force or a property of space itself that is pushing the universe apart, driving the expansion, making galaxies accelerate away from each other faster and faster with each passing billion years. We do not know what dark energy is. We cannot detect it directly. We can only infer it from the way the universe is behaving, the way it is growing, the way distant supernovae appear slightly fainter than they should if the expansion were slowing down rather than speeding up. So when you look at the darkness of space, you are not looking at nothing. You are looking at something we cannot see, something that makes up 95% of everything that exists. The darkness is not empty. It is full of things we have no senses for. No instruments sensitive enough to reveal, no language adequate to describe. The darkness is the majority of reality. We are the small, bright exception, a tiny fraction of a fraction, lighting our little fires against an incomprehensible dark that preceded us by billions of years and will outlast us by trillions more. And yet, here you are, here we are, small and temporary and bright. That is where we will pause for tonight. The darkness, as we've been exploring it, is not simply an absence. It is a condition, a property of the universe so fundamental, so pervasive, that light, the thing we tend to think of as the natural state of things, is actually the rare exception. The darkness was here before the stars. It will be here after the last one goes cold. And in between, in this brief luminous era we happen to inhabit, we move through it, study it, fear it, and slowly, carefully begin to understand it. Let us go deeper now. Let us follow the darkness into places where it becomes something even our scientific instruments struggle to describe. Consider what happens to your vision in conditions of true sensory darkness. Not the soft dark of your bedroom, not the theatrical black of a movie theater, but a darkness where no photon reaches your eye for minutes, then hours. Your rod cells, already exquisitely sensitive, become more so. The rhodopsin molecules inside them, the pigment that bleaches when struck by light and triggers a nerve signal, regenerate fully. Your eyes reach their maximum possible sensitivity. You are now, in a biological sense, as capable of detecting light as you will ever be. And still, in the true darkness of space, there is nothing for that sensitivity to find. The human eye, under ideal conditions, can detect as few as a handful of photons entering the pupil. Some research suggests even fewer, perhaps a single photon in the right circumstances. That is a remarkable thing. A receptor so delicate it can respond to the smallest possible unit of light. And in the interstellar void, in the space between galaxies, in the quiet dark between everything, even that extraordinary sensitivity finds nothing to hold on to. Your visual cortex, that vast region of brain tissue at the back of your skull that occupies more neural real estate than any other sensory system, receives no input. And the brain does not respond to this with quiet acceptance. It responds the way it responds to most forms of deprivation, by searching, by generating, by filling the absence with something it has made itself. Studies conducted in extremely dark environments, deep cave systems, isolation chambers, lightless rooms where subjects spend days without any visual input at all, show a consistent pattern. The longer a person is deprived of visual information, the more likely they are to begin seeing things that are not there. Not in a disturbing way, or not always. Sometimes simply patterns, geometric shapes, slow pulses of color, the impression of something moving at the edge of perception. The brain is not malfunctioning when this happens. It is doing exactly what it evolved to do, processing signals, finding structure, constructing a model of the world. When the signals stop, it begins inventing them. Astronauts on long missions report something similar. Not hallucinations exactly, but a quality of attention that the darkness produces. A heightened awareness of the void on the other side of the hull. A persistent, low-level consciousness of the fact that a few centimeters of metal and composite material separate the bright, familiar interior of the spacecraft from the absolute nothing outside. You know it intellectually before you go. But there is a difference between knowing it and feeling it, between understanding in your mind that the void is right there and understanding it in the older, quieter parts of the nervous system that do not respond to rational argument. This is part of what makes long-duration spaceflight different from any other kind of physical challenge humans have attempted. The body can be conditioned, muscles can be maintained, bone density can be managed with exercise. The cardiovascular system adapts. These are problems with solutions, engineering problems in a sense, challenges that respond to effort and technology and time. But the darkness outside is not a problem with a solution. It is just there, unchanging, absolute, patient. Every time you look out the window, it is the same. Every hour of every day of a mission lasting months or years, the view is identical. Black space and distant stars that never move and never change and offer no information about how much time has passed or how far you have traveled or whether home still exists. The human mind was built for variety, for the endless small changes of a living environment, wind shifting, light moving across a room as the sun travels, sounds that come and go, faces that change expression, temperature that rises and falls with the time of day. All of this feeds a brain that needs to be constantly updated, constantly recalibrating its model of the world. In deep space, that river of information slows to almost nothing. The world outside the window simply does not change, and the brain, denied its normal diet of small variations and subtle signals, begins to struggle. Think about what you rely on to feel oriented in your own life. Not just physically oriented, knowing where you are in a room, but temporally and emotionally oriented. The quality of light in the morning tells you the day is beginning. The smell of coffee, the sound of traffic or birdsong outside. The way the light changes through the afternoon, going golden and then amber, and then finally the deep blue of dusk. These are not just pleasant things. They are anchors. They are the structure your nervous system uses to locate itself in time, to maintain a sense of continuity between what happened yesterday and what is happening now. In space, away from Earth, those anchors are gone. The sun, if visible at all, is a point of light rather than a disk, and it does not move through the sky in the way your body expects it to. There is no sky in the usual sense. There is no morning and no evening in any natural form. There is the light inside the spacecraft, carefully programmed to mimic a day and night cycle, an artificial approximation of something your biology evolved to need. And there is the darkness outside. The Apollo 8 crew, the first humans to travel to another world, understood this in December of 1968. Frank Borman, Jim Lovell, and William Anders left Earth orbit and traveled to the Moon, crossing a distance of roughly 250,000 miles, farther from home than any human being had ever been. When they passed behind the Moon, radio contact with Earth was lost. For approximately 45 minutes, they were completely alone in a way that word has never quite meant before or since. On the far side of the Moon, out of sight of Earth, out of communication with anyone, surrounded by the darkness of space with only the gray cratered surface below and the void above. Jim Lovell described looking out into that darkness and experiencing a quality of aloneness that defied description. The sun illuminated the lunar surface with brilliant, harsh, unfiltered light, creating shadows so black they appeared to be holes in reality. And beyond the edge of the Moon, beyond that sharp transition between sunlit rock and shadow, there was nothing. Not the gentle gradations of darkness on Earth, where shadows soften at their edges and ambient light fills the spaces between. Things. Just an absolute boundary. One side, light. Other side, dark. No middle ground, no softening, no transition. Because there is no atmosphere to scatter the light, to carry it into corners, to make it gentle and diffuse and forgiving. In space, light is brutal and darkness is total, and there is nothing in between. When they came around the other side of the Moon and saw the Earth rising above the lunar horizon, Lovell later said the feeling was indescribable. That small blue and white sphere, so vivid and alive against the dead black sky, was the only thing of color in the entire universe as far as they could see. Everything else was either gray rock or absolute darkness. And there was home, fragile and bright and impossibly alone. William Anders took a photograph during that orbit that would become one of the most famous images ever made. The Earth rising above the Moon's surface, half illuminated, blue and white and brown, floating against a blackness so complete it looks like the sky itself has been erased. That photograph, which people call Earthrise, changed something in human consciousness. It showed us what we look like from outside. It showed us the darkness that surrounds us, that has always surrounded us, that we have been floating inside without fully knowing it. The Earth is not the universe. The Earth is a small bright island in the universe, and the universe is mostly dark. Consider now what this means for the future, not the near future of the next. Few decades when we may return to the Moon and eventually reach Mars, but the longer future, the future measured in billions of years, the future in which the darkness we see today looks almost crowded and bright by comparison to what will come. The universe is not in its youth, but it is not yet old. We live approximately 13.8 billion years after the beginning, which sounds ancient, but the estimated lifespan of the smallest, most common type of star, the red dwarf, is in the range of 10 trillion years. By that measure, we are in the early morning of cosmic history, the first thin light before sunrise. Stars are still forming. Galaxies are still evolving. The universe is still, in a meaningful sense, getting started. But the peak has passed. Star formation in the universe reached its highest rate approximately 10 billion years ago, in a period cosmologists call cosmic noon, when gas clouds were collapsing into stars at a rate many times higher than today. Since then, the rate has been declining. The universe is slowly, incrementally, cooling its fires. Not quickly, not alarmingly, not in any way that will matter for billions of years to come. But the direction is clear. We are on the downslope. The universe is heading, by slow, inevitable degrees, toward a darkness deeper than the one we see today. In roughly 100 trillion years, the last star will exhaust its fuel and go dark. That number is almost impossible to hold in the mind. 100 trillion years. Written out, it is one followed by 14 zeros. Our entire cosmic history, from the Big Bang to this moment, would need to be repeated roughly 7,000 times to reach that point. The last stars will not go out dramatically. They will simply cool. The smallest ones will fade from red to brown to black, spending their final energy in a slow, imperceptible decline. And then they will be cold, dark objects drifting through a universe that no longer produces light. After that comes what physicists call the degenerate era, a universe populated by the remnants of stars, white dwarfs slowly radiating away their stored heat over vast timescales, neutron stars spinning down over millions of years, black holes gathering the remaining matter around them, planets orbiting dead suns in perpetual night, no new stars forming, no light being generated anywhere, just these cooling relics and the darkness between them. Think about a planet in that era. Perhaps a rocky world that once orbited a yellow star, the way Earth orbits our sun. The star has been gone for billions of years, collapsed into a white dwarf that has since cooled to something cold and dark, no longer visible except as a distortion in the faint background. The planet continues to orbit this dark remnant out of nothing more than gravitational habit. Its surface, if it has one, is at temperatures close to absolute zero. There is no sunlight. There is no warmth. There are no seasons, no tides, no weather. Just the planet turning slowly in the dark, carrying its frozen geology around a dead star, year after meaningless year. This is the future. Not next week, not next century, but eventually. This is where the physics points, inexorably and without exception. And yet, this too is not the deepest darkness. Black holes, those extraordinary objects that arise when massive stars collapse at the end of their lives, or when enough matter accumulates in one place to create a gravitational well from which nothing can escape, represent something different. Not merely dark in the sense of not emitting light, actually, definitionally, absolutely dark. Light that crosses the boundary of a black hole, the event horizon, does not slow down. It does not dim. It simply ceases to exist as far as the outside universe is concerned. It is gone. The event horizon is not a surface you could stand on or touch. It is a point of no return, a boundary in space-time beyond which causality itself changes. Once you are on the other side, the future only points inward, toward the singularity at the center. There is no direction that leads out, not for light, not for anything. Looking at a black hole from outside, you would see a circular region of absolute darkness. A hole in space where the stars behind it should be visible, but are not. The black hole does not just fail to emit light, it captures the light of everything behind it, warping space-time so severely that photons which should travel in straight lines are bent into curves that spiral inward and never escape. The region is not empty in any ordinary sense. It contains compressed matter and enormous gravitational energy. But it is dark in a way nothing else in the observable universe is dark. Not dark because it lacks light sources. Dark because it eats light. Dark because the laws of physics inside it are so extreme that visibility itself becomes impossible. The images of black holes that have been produced in recent years, the famous image of the massive black hole at the center of the galaxy Messier 87, and later the image of the black hole at the center of our own Milky Way, show this with startling clarity. A ring of brilliant orange and red, superheated gas being accelerated to near the speed of light as it spirals toward the event horizon. And at the center, a circle of absolute black. A shadow so perfect it looks like a hole punched through the photograph. The blackness at the center is not shadow in the ordinary sense. It is the black hole's absence, the place where light simply does not come from, can never come from, will never come from. If you could somehow survive the tidal forces near a large black hole, forces which in reality would tear apart any ordinary matter before it got remotely close and crossed the event horizon, you would enter a darkness beyond anything the universe outside contains. No light from outside could follow you in. The entire external universe, every star and galaxy and nebula and distant smear of ancient light, would be cut off. You would be inside a region of space-time causally disconnected from everything else that exists. The darkness would be total, final, and permanent in the most absolute sense that word can mean. This is perhaps the one true boundary of darkness in the universe. Not just the absence of light, but a place where light goes to disappear. Let us come back from that edge and think about something closer to home, something more immediate, more connected to the experience of lying here in the dark tonight. The darkness of space does not stay out there. It has been shaping human psychology, human culture, human consciousness for as long as there have been humans. Long before any astronaut floated in the void and described what the true dark felt like, long before telescopes and space probes and photographs of the Earth from the moon, human beings have been looking up at the night sky and feeling something that resists. Simple description. Something between wonder and fear, between smallness and expansion, between the urge to understand and the recognition that full understanding may be permanently beyond reach. Ancient peoples looked up at the same darkness we look up at, saw the same stars, felt the same pull, and they did what humans do when faced with something vast and unknown. They built stories, constellations, those patterns imposed on random arrangements of stars by minds that need to find shape in chaos, became the scaffold of entire mythologies. The Milky Way became a river of souls, a road of the gods, the spilled milk of a divine mother, a bridge between worlds. The darkness between the stars was populated with monsters and heroes and the spirits of the dead. These were not mistakes. They were not failures of science. They were the natural response of a storytelling species to the overwhelming reality of the cosmos. The darkness demanded interpretation. The universe required a narrative, and humans, being what we are, provided one. What is interesting is that even now, with all the science we have, with all the measurements and theories and observations and instruments, the darkness still produces something very similar in us, a reaching, a need to understand that exceeds our current capacity to do so. We know what a black hole is, or we know the mathematics that describes one. We know the age of the universe approximately. We know why the sky is dark, but the knowing does not dissolve the feeling. The darkness still asks something of us. It still opens something in the chest, some space that is not quite fear and not quite wonder, but contains elements of both. Consider for a moment what you are doing right now. You are lying in the dark. Around you, the familiar shapes of your room, made invisible by the absence of light. Above you, beyond the ceiling, beyond the atmosphere, beyond the orbit of the moon and the orbit of Mars and the orbit of the distant outer planets, the darkness extends in every direction. You are at the bottom of an ocean of space, held to a small rocky world by gravity, breathing air that exists because of a series of extraordinary coincidences involving the composition of our planet and the distance of our star and the presence of life-generating chemistry that transformed a bare rock into a living world over the course of 4 billion years. You are here, in this specific place, at this specific moment, which is an extraordinarily unlikely thing to be. The universe does not require any of this. It got along perfectly well for 9 billion years before our planet formed. It was perfectly, utterly dark for hundreds of millions of years before the first stars lit. It has been mostly darkness for all of its existence. You are the exception. Your existence, your awareness of the darkness, your ability to lie here and think about what it means, is the strange and improbable thing, not the darkness. The darkness is the baseline. You are the anomaly. There is something deeply restful in that thought if you let it settle. You do not have to be the center of things. You do not have to matter cosmically. The universe does not require your significance. It simply is, vast and dark and indifferent, and you are here inside it for a brief and improbable time, aware of it, curious about it, capable of finding it beautiful. That is enough, more than enough. It is extraordinary. The darkness is not empty of meaning. It is full of everything we do not yet understand, which is most of everything. Dark matter, invisible and massive, threading through every galaxy. Dark energy, driving the expansion of space with a force we cannot explain. Quantum fluctuations in the vacuum, virtual particles appearing and vanishing in fractions of seconds, the fabric of reality shimmering at scales too small to see. Neutrinos streaming through every cubic centimeter of space, including the space inside. Your body, barely interacting with ordinary matter, carrying information across the universe in particles so shy they pass through entire planets without noticing. The darkness is not nothing. It is everything we have not learned to see yet. There is a word in physics: vacuum. It comes from the Latin for empty, and for centuries it was understood to mean exactly that, a region containing nothing at all. Scientists tried to create perfect vacuums in their laboratories, pumping all the air and gas out of sealed containers, getting closer and closer to true emptiness. And what they discovered, as their instruments became sensitive enough to look, was that there is no such thing as a perfect vacuum. Even a region of space containing nothing, from which every particle of matter has been removed, is not actually empty. It seethes. It fluctuates. Virtual particles appear and annihilate in intervals so brief that they cannot be directly observed, but whose effects can be measured, have been measured, are real. The vacuum is not empty. It is full of the potential for things to exist, momentarily, and then not. This is one of the stranger discoveries of 20th century physics, and its implications are still being worked through. The darkness of space, the void between stars and galaxies, is not a passive absence. It is an active, if invisible, presence. It has energy. It has structure at scales far too small for light to illuminate. It may be connected, through mechanisms we do not yet understand, to dark energy itself, to the force that is pushing the universe apart. The darkness knows something we do not. Now let us think about something more immediate, more human. What the darkness of space means not for the fate of the universe, but for the fate of us, specifically, as a species deciding whether and how to leave our planet and venture into that void. The challenge is not only technological. We know this, at least in broad terms. We can build spacecraft. We can develop life support systems. We can figure out propulsion and navigation and the engineering of environments capable of sustaining human life in the absence of everything that sustains it naturally. These are hard problems, but they are problems of the kind that human ingenuity has always eventually solved. They respond to effort. They yield to persistence. They have solutions. The psychological challenge of the darkness is different. It does not yield to engineering. It does not respond to better materials or more efficient rockets. It is a challenge that lives inside the people making the journey, in the deep, ancient, irrational parts of the nervous system that were shaped by a world where darkness meant danger, where complete sensory deprivation was a signal that something had gone profoundly wrong, where the absence of light was information: find shelter, make fire, do not venture out. Those instincts are still there. They are still running, quietly, beneath the rational. Understanding that everything is fine, that you are in a spacecraft, that you are tethered and suited and in communication with a team of experts. The rational mind can be convinced. The older mind is harder to reach. It sees the darkness beyond the window, and it registers in its ancient wordless way that this is not right, that a darkness this complete has never been survived before, that nothing in the long history of everything that lived and breathed before you has ever been in a place this dark and come back to tell about it. The astronauts who have spent time in deep shadow during spacewalks describe something like this: a primal unease, a difficulty that is not physical, not related to the work itself or the equipment or the temperature or the pressure, just the darkness, just the fact of being in it. The suits provide light, of course, beams mounted at the helmet. But beyond the edge of that illuminated bubble, the darkness is absolute. A tool that drifts out of the light, vanishes instantly and completely, as though it has ceased to exist. The station structure, 3 feet away, is invisible in shadow. You know it is there. Your hand can reach it, but you cannot see it. The evolutionary signal this sends is danger, vulnerability, the inability to perceive your environment, to see what is coming, to find the edge of things. For most of human existence, this signal was accurate. The darkness was when predators hunted. The darkness was when you could not see the edge of the cliff or the surface of the river or the movement in the grass. The darkness was when you needed fire, needed shelter, needed another set of eyes. The response this generated, the heightened alert, the racing pulse, the careful stillness, the urge to make light somehow, was the correct response. It kept your ancestors alive. In space, the response is still there, and the danger it was calibrated for is not. There are no predators in the interstellar void. There are no cliffs, no rivers, no movement in the grass. There is only the darkness itself, indifferent, boundless, and entirely unconcerned with whether you find it frightening. The fear is ancient and real and completely, in a certain sense, inappropriate to the actual situation. But it comes anyway, because evolution does not care about appropriateness. It cares about survival. And for most of the time, survival required being afraid of the dark. Future crews heading to Mars will need to find ways to live with this. Not to eliminate the response, which may not be possible, but to accommodate it. To build lives and routines and environments that acknowledge the darkness without being controlled by it. Windows that can be covered. Interior spaces designed to feel complete and warm and bounded. Lighting systems that maintain the illusion, or perhaps the reality, of a day and night cycle even when the external environment offers nothing of the kind. These are not luxuries. They are as essential to the mission as propulsion and life support. A crew that cannot function psychologically cannot function at all. The journey to Mars takes somewhere between 6 and 9 months with current technology. Imagine that duration. Not in the abstract, but specifically. 6 months of looking out a window at essentially unchanging darkness. Earth, in the first weeks, still visible as a bright dot, then a dim dot, then indistinguishable from a star, then gone. Mars, ahead, a slowly brightening point of red light that grows almost imperceptibly over months of travel. And between them, the void. Black and still and absolutely the same every time you look. The spacecraft becomes everything. Its interior, its sounds and smells and the faces of the people inside it is the entire world. There is no outside to escape to. There is no walk around the block, no drive through changing scenery, no weather that brings variety to a monotonous day. There is the corridor between compartments, the same corridor walked for the 1000th time. There is the window, and beyond it, the darkness. Communication with Earth is real, but limited. At maximum distance from Mars, a radio signal takes roughly 22 minutes to travel from the spacecraft to a receiver on Earth, and another 22 minutes for a reply to return. You cannot have a conversation. You can send a message and receive an answer 44 minutes later, which is less like talking and more like exchanging letters. The intimacy of voice. The comfort of knowing someone is on the other end of the line, listening in real time, is gone. You send your words into the darkness and wait, and eventually, from across the void, something comes back. This is the emotional reality of deep space travel, and it will need to be taken seriously, not just by the engineers designing the spacecraft, but by the people making the journey. They will need resources that have nothing to do with oxygen, or calories, or radiation shielding. They will need books, and music, and ways to mark time, rituals of normalcy, small repeated actions that give structure to days that might otherwise blur into each other in the continuous darkness. They will need each other, in the most basic and irreducible human sense of needing another person. Someone to look at, someone to hear, someone who understands what this is, who is in the same darkness and also afraid, and also finding ways to be not afraid. This is where we will pause tonight. The darkness, by now, has become something familiar. You have been traveling through it for a while, through the interstellar void and the intergalactic emptiness and the perfect black of a black hole's shadow and the ancient pre-stellar dark of a universe not yet lit. You have felt the edges of it, the way it sits against human psychology like something too large to be held all at once, the way it asks something of us that we are still figuring out how to give. Let us slow down now. Let the ideas settle like sediment in still water. There is a quality to the darkness that we have not yet fully named. Not its size, which we have touched on. Not its age or its physics or its effect on the mind. Something simpler. Something that sits underneath all of those things and holds them together. The darkness is the default. It is the resting state of the universe. Everything that is not dark, every star and galaxy and nebula and warm planet with its oceans and clouds, is an interruption. A brief, improbable deviation from the baseline. The universe did not begin with light. It began with a hot, dense state that eventually cooled into darkness, then slowly, over hundreds of millions of years, generated light again when the first stars formed. And it will end in darkness. When the last stars cool and the last black holes evaporate and space itself expands beyond any possibility of meaningful interaction. Light is the temporary thing. Darkness is the permanent one. That is a strange thought to carry, but it is. Not a frightening one. Not really. Not when you hold it quietly and let it be what it is. The darkness is not hostile. It is not malevolent. It does not have intentions. It simply is the condition of a universe that has not been persuaded otherwise by the presence of a star or planet or a species of curious storytelling creatures who lie awake at night wondering what it all means. The darkness does not mean anything. It just exists, immense and patient, in all the spaces between the lights. And the lights exist too. They are real. The fact that they are temporary does not make them less real. The fact that they are exceptions does not make them less significant. If anything, the darkness makes them more significant. The way a single sound in a silent room is heard more fully, more completely than the same sound made in a crowd of other sounds. The stars shine against the dark. Life exists against the dark. You lie here, breathing in the dark, aware of the dark, which is itself an extraordinary thing. Because the dark is not aware of you. Think about what it means to be aware, to be the kind of thing that knows it exists, to be the kind of thing that looks at a dark sky and asks why it is dark, and then finds an answer, and then asks another question. The universe spent almost 14 billion years producing exactly this, and in most of the universe it has not produced it at all. Dark matter does not wonder about dark energy. Black holes do not contemplate their own event horizons. The void between galaxies is not curious about the void between stars. Only here, only on a small rocky planet around an ordinary star in the outer suburbs of one spiral galaxy among hundreds of billions, did matter arrange itself into something that can look up and think. That can feel small. That can feel wonder. That can feel, in the quiet dark just before sleep, a strange, gentle gratitude for the improbable fact of its own existence. You are the universe being aware of itself. That is not a poetic metaphor. It is a description of what is physically happening when you think. The atoms in your body were forged in the interiors of stars that died before our sun was born. The carbon in your cells, the iron in your blood, the calcium in your bones. All of it was made inside a stellar furnace and scattered across space by a supernova explosion and eventually gathered by gravity into a new star system and a new planet. And eventually, after 4 billion years of chemistry and biology, into you. You are made of the stuff of stars. You are the cosmos bent back on itself, looking at its own darkness and asking what it is. That is worth sitting with for a moment, here in the quiet. The darkness outside your window tonight is the same darkness that stretches to the edge of the observable universe and beyond. the same darkness that existed before the first stars and will exist after the last one. You are floating inside it, cushioned by an atmosphere and warmed by a star and held by the gravity of a planet, but inside it nonetheless. Always inside it. The light we generate, the light we live by, is a local phenomenon, a small and temporary brightness in a universe that is mostly dark, and somehow this is not a depressing thought. Or it does not have to be. It can be something else. It can be the thing that makes this moment, this specific moment of being alive and warm and breathing, feel like the gift that it is. Not taken for granted, not assumed to be permanent. Just here, now, briefly, improbably, beautifully. Now let us follow the light as it travels, because there is something in the way light moves through the dark that deserves to be understood slowly. Light travels at approximately 186,000 miles per second. That is fast in any human terms. At that speed, you could circle the Earth 7.5 times in a single second. You could travel from here to the Moon in about 1.3 seconds. From the Earth to the Sun in about 8 minutes. These numbers are impressive, and they make light feel very fast, which it is, until you compare it to the distances it has to cross. The light reaching your eyes from the nearest star beyond our Sun, that small red dwarf Proxima Centauri we mentioned earlier, left its surface 4.24 years ago. When that light began its journey, 4 years have passed. 4 years of your life. Perhaps you were somewhere different. Perhaps some things that matter to you now did not exist yet. And all that time, that light was traveling, crossing the void between star systems at the fastest speed physics permits. And it has only just arrived. From the Andromeda Galaxy, the light took 2.5 million years. When it left, the most recent common ancestor of humans and chimpanzees was still alive. Our species did not exist. There were no humans to see it go. And now, here it is, arriving on Earth, entering telescopes and human eyes, carrying information about a galaxy that looks, to our eyes, as it looked 2.5 million years ago, before our species existed to receive it. This is one of the more quietly astonishing facts about the universe. We do not see it as it is. We see it as it was. The farther we look, the further back in time we see. The most distant galaxies visible to our most powerful telescopes are showing us light that left them when the universe was only a few 100 million years old, when those galaxies were young and hot and forming stars at extraordinary rates. Those galaxies are ancient history. They may have changed completely in the billions of years since that light began its journey. We do not know what they look like now. We cannot know. The light showing us their current state has not arrived yet. Will not arrive for billions of years. We are seeing the universe's past, layered in depth, older the farther we look, the darkness between the galaxies threaded with ancient light still traveling toward us after journeys lasting billions of years. Consider what is still on its way. Right now, at this moment, light from galaxies we have never seen is traveling toward Earth. Light that left its source millions or billions of years ago, crossing the void at the speed of physics will allow, carrying information about objects that may no longer exist in the form they had when that light departed. Some of that light will arrive in our telescopes next year. Some of it will arrive in 1,000 years. Some of it will arrive in 1,000,000 years, long after we are gone, and if something with eyes is here to receive it, they will see something we will never see. They will look into the same dark sky and see different depths of it, different ancient light, a universe slightly more revealed. We are temporary receivers in a very long transmission. This way of thinking about the universe as a place where information travels at a finite speed across enormous distances has an interesting implication. When we look at the night sky, we are not seeing a single moment. We are seeing a collage of different moments, layered in depth and time. The moon as it was about 1 1/3 seconds ago. The sun as it was 8 minutes ago. The nearest stars as they were 4 years ago. The bright stars of the Orion constellation as they were hundreds of years ago. The Andromeda Galaxy as it was 2.5 million years ago. All of these different moments are being received simultaneously by your eyes, collapsed into a single image, a single sky, when in fact what you are seeing is more like a long exposure photograph of time itself, all of history visible at once if you know how to read it. The darkness between those points of light is not empty time. It is time that has not yet been filled. Space through which light is traveling right now that has not yet reached anything. The universe is full of messages in transit, information crossing the void, light that left its source long ago and has not yet arrived anywhere. The darkness is threaded with these invisible journeys, these patient photons traveling for millions of years toward destinations they cannot know. And some of that light will never arrive. Not everywhere, not to every possible receiver. The expansion of space means that there are galaxies so distant, receding so fast because the space between us and them is expanding faster than light can cross it, that their light will never reach us. They are beyond what physicists call the cosmic horizon, the edge of the observable universe. Not a physical boundary you could reach, but a limit set by the speed of light and the rate of expansion. Beyond it, things exist. We know they do. The universe does not end at our horizon, but we will never see them. Their light is traveling toward us, but the space it has to cross is growing faster than the light can travel. They are, in a very precise sense, permanently invisible to us. As the expansion continues, more galaxies will cross that horizon. They will not disappear. They will simply pass beyond the edge of what is accessible to us, their light stretched into invisibility by the expanding space between us and them. The observable universe in a distant future era will be smaller than it is today. Smaller not because space has contracted, but because light has more distance to cross, and the expansion has made more of that distance uncrossable. Beings in that future era, looking up at their night sky, will see far fewer galaxies than we see today. They might not even know about the expansion, because all the evidence for it, the distant galaxies whose recession tells us space is stretching, will have faded beyond detection. They will think they inhabit a static, bounded universe, not knowing that all around them, in the darkness they cannot see past, is a cosmos far larger than their instruments can reach. They will be right about their observable universe and wrong about the universe as a whole, and they will have no way to know the difference. We are fortunate to live now, in this era when the evidence is still visible, when the distant galaxies are still detectable, when the cosmic microwave background, the faint afterglow of the Big Bang itself, still fills the sky at microwave wavelengths that our instruments can measure. In 1 trillion years, that background will have faded to unmeasurable. The evidence of the beginning will be gone. We can still see it. We have the extraordinary privilege of living in a universe young enough, bright enough that the story of its own origin is still faintly readable in the darkness of the sky. That is the darkness we live inside, a darkness that still contains its own history, visible to those who know how to look. Let us come back once more to the human scale of things, to the intimate and specific experience of lying in the dark, because that is where you are, and it matters. You have been breathing slowly while these ideas have moved through you. The universe has been doing its universe things, expanding and cooling and threading the void with ancient light, entirely without your assistance or approval. The stars have been burning. The black holes have been accumulating. The virtual particles have been appearing and vanishing in the quantum foam of empty space. All of this has been happening, and you have been here, still, warm, thinking. This is what you do in the dark. You think, you drift, you let the thoughts come loose from their daytime urgency and float a little, the way objects float in microgravity, gently, without direction, bumping into each other occasionally and then separating again. This is not wasted time. This is some of the most important time there is. The darkness does something to the mind that the light does not do. It removes the pressure of being seen. It softens the hard edges of the self. It lets things be uncertain and unresolved without that uncertainty feeling like a problem to be solved immediately. The universe is mostly dark and mostly quiet and mostly empty, And within it, briefly, here, there is this: a warm body, a thinking mind, the sound of breathing, the small sounds of a house settling, the ordinary miracle of being alive in the dark. Consider how rare this is, not emotionally, but statistically. The volume of the observable universe is approximately 415 quintillion cubic light-years. The fraction of that volume containing anything at all, any matter, any energy, any structure, is very small. The fraction containing life is smaller still. The fraction containing conscious life, life that is aware of itself and its surroundings and the darkness around it, may be the smallest fraction of all. We do not know if there is any other conscious life in the universe. We have not found any. We have been looking, in our limited way, for a short time, using the instruments our particular biology and technology have produced. The absence of evidence is not evidence of absence, but the silence of the cosmos so far is, at minimum, a reminder that whatever you are, the kind of thing that lies awake in the dark thinking about existence, is not obviously common. You might be part of something extremely rare. The universe might have been doing all of this, all of the star formation and galaxy evolution and quantum fluctuation and cosmic expansion, for 14 billion years, and in all that time produced only a handful of places where something like you is possible. Or it might have produced billions of such places, and we simply have not yet found any of them. We genuinely do not know. What we do know is that you are here. Whatever the statistics, whatever the probability, the result is you, now, in this darkness, with this awareness. And that is not nothing. That is, in fact, everything that the universe has managed to produce that is capable of noticing the universe. Everything that can look at the darkness and ask what it is and feel something about the answer. Have you ever wondered what it would be like to be the last light? Not the last person, not the last civilization, but the last photon, the last particle of light produced by the last star in the very far future, traveling through a universe that has gone completely dark, crossing the void between the cold remnants of what were once stars and planets and perhaps worlds with life. That photon would travel through a universe that no longer contains anything capable of receiving it. It would travel through the darkness forever, or until it encountered something, which it might never do, because the universe would by then have expanded to a size so incomprehensible that the average distance between anything and anything else would make our current universe seem infinitely dense by comparison. That is the future, eventually, and it is so far away that the word eventually becomes meaningless. 100 trillion years just to reach the era when the last star goes dark. Then trillions more for the remnants to cool. Then unimaginable spans for the black holes to evaporate. The timescales involved make the 14 billion years of cosmic history feel like a single breath. And on that breath, we exist. On that single intake of cosmic breath, everything that has ever lived or thought or felt anything has happened. Right here, on this small bright world. We are the briefest of interruptions in a very long silence. And yet, the interruption matters. Not to the universe, which does not deal in mattering, but to itself, to us. The fact that the universe contains, for this brief window, something that knows it contains something, is not trivial. It is the most complex and surprising thing the cosmos has managed to produce, and we are it. So lie here a little longer in the dark. Let the darkness be what it is. It is not your enemy. It is not a threat. It is the background against which you exist, the silence that makes your existence audible, the void that makes your presence possible to notice. You are warm in the dark. You are breathing in the dark. Your heart is beating in the dark. Your mind is moving in the dark, slowly now, gently, following these long, slow thoughts the way water follows the shape of the land it flows through, not resisting, just moving. Finding the path of least effort, settling into the quiet. The darkness is vast. You are small. These two things are both completely true, and somehow, held together, they produce something that is not fear and not despair, but something quieter and more settled. A sense of proportion, a sense of place, You know where you are, which is inside the universe, which is inside the dark, which is inside a moment that will not come again. This moment, right now, is not repeatable. The configuration of everything, the specific arrangement of atoms that constitutes you in this place at this time, the exact quality of quiet around you, the particular distance the universe has expanded to in this millisecond. None of it will ever be repeated. Everything flows and changes and expands. This moment is singular, and then it passes, and another singular moment takes its place, and you are in it, continuously in it. The darkness holds you in it, in fact, by making you still enough to notice. This is one of the things the dark does. It stops the performance of the day. It closes down the displays. It turns off the signal that the light carries, which is see, be seen, move, act, respond. In the dark, those signals quiet, and what is left is just this, just the fact of being here, just the breathing and the warmth and the slow weight of a body that has been moving all day and now finally, gratefully, is still. The universe is 14 billion years old, and it will last for unimaginable spans beyond this moment. And in all of that immensity, you have this small, quiet dark, this particular night, this breath following that breath. The thoughts slowing now, moving less quickly, taking longer to form, drifting a little before they complete themselves. The stars are out there, burning. The black holes are doing their patient work. The quantum vacuum is seething with its invisible fluctuations. The ancient light from distant galaxies is traveling toward us through the dark, patient photons that have been crossing the void for billions of years and will arrive eventually, whether we are here to receive them or not. All of it is happening. All of it will continue to happen. The universe does not need you to be awake for it to proceed. You can let it go. The darkness between stars is not empty. You know that now. It is threaded with invisible light and dark matter and quantum activity and the long, slow history of a cosmos still unfolding. But the darkness around you tonight is gentler than that. It is the darkness of a room, of a house, of a night that will pass into morning, of a world that will still be here, of a life that continues. The universe is mostly dark, and the dark is fine. The dark is where everything rests. The dark is where the stars go when they are done burning, and the day goes when it is done, and the mind goes when it is ready to stop working and just be. The dark is not the absence of the good things. The dark is what holds the good things when they need to be held. You are being held right now. The questions you have been carrying, the ones that felt urgent this morning, they are still there, but they are quieter. They will be there in the morning. They do not require solving tonight. Tonight, they can just rest, the way everything rests in the dark, the way the light rests when the star is on the other side of the planet, the way the universe itself rests in the long, quiet stretches between one era of light and the next. Let the thoughts drift. Let them take their time. The darkness is patient. It has been here much longer than you, and it will be here after, and right now is simply here with you, this ordinary darkness of a night that is like other nights. Which is to say, unlike any other night that has ever been or will be, because this one is yours, now, in this specific dark, with the specific weight of this day behind you and the specific unknown of tomorrow still ahead. The cosmos is very large and very dark and very old, and you are very small and very warm and very briefly here, and somehow all of that resolves into something that feels, in this moment, like enough, like more than enough. Like the exact right amount of everything. Sleep now. The darkness will keep watch. It always does. Good night.